Very a joyful moment and very proud moment to receive this award. I am very much grateful to the Alumni Association and the committee members who have selected me and considered me as awardee. It is also a pleasure to receive this award from PG Venkatraman sir. We are known, I mean, he is very much popular with his short name PGV in the industry. Probably everybody knows him with that name only. In Stoke, we listen very much about him that he has done some projects which are extraordinary, and that is the legacy he has left for us. And today I receive award with his presence. That is my fortune. I definitely today miss very much SD Limay sir, who was very key person in my early days of career in Stu. Which are the projects I am going to present. The first project, he was in standing very much back of, so I could do that. Today I am going to speak about three projects which I did. There I did many projects as such, but in the short time of 30 minutes, I could cover I think three projects. Slide next. So generally the bridges are designed considering the functional requirement. So the span is taken considering the whatever the requirement to cross over. I mean, if something is there in the junction or something, then that we have to clear. So the span is chosen from that perspective. Uh, uh, the two projects I did were the same, crossing over the railways. The road has to cross the railway line, and the demand from railway was that there should not be any pier in the railway boundary. So the long span bridge was the first came across for my work. Then the second challenge was constructing this bridge. Any bridge, the design is one part, the construction is another, and the bridge design as well as construction both goes hand in hand. And so I am talking more about the construction engineering today rather than the design work. For long span, the possible solutions could be the arch bridge, extra dose bridge, or cable stayed bridge. But being a cable stayed bridge, very small in its depth, so it was chosen. And these solutions were adopted in two locations. One is at Nagpur and one is at Bardhaman, West Bengal. The third one I will talk today is basically architectural driven project, that is Durgam Chedu project. Aesthetic was given more importance and that bridge was done. So which was a new experience for me. Generally the bridge designers don't came across with the architects, so that the third bridge will be interesting for everybody. So today's presentation will be on these three bridges. One is cable stayed bridge at Nagpur, then the second is cable stayed bridge at Bardhaman, West Bengal, and the third is Durgam Chedu bridge, Hyderabad. So for Nagpur, the total span length was 200 meter, and the pylon was placed at this center, not exactly at the center. So the two spans on the right and left were not exactly balanced. One was 88 meter, another was 112 meter. It was a 6-lane bridge, so two separate 3-lane carriageway were there. The bridge locations we can see in the image, that is across the Nagpur railway station, which is the busiest station. It is a Rajdhani route. So on the right side of the plan we can see the Nagpur station platforms, and on the left side we could see the railway yard, and the pylon was placed somewhere in between, so that that place was available for putting the pylon. Then the railway has demand that they have to get the clear boundaries because their yard modification, yard remolding was proposed. Then we can see there is a junction on the right side bottom where we could not cross it. I mean, that was the key point of it. At the same time, we have to achieve the required clearance at the first platform. So the distance available was just about 100 meter, and there the solution could be the small depth superstructure. So the cable stayed bridge was chosen. The general arrangement of cable stayed bridge is like shown in the drawing. Pylon height is almost 45 meter above the deck. the one side of bridge is 112 meter, other side is 88 meter. The two separate pylons were there. The existing bridge was at the right side. So first the left bridge was constructed, then the existing bridge was demolished, and then the second was constructed. The deck is just 1.2 meter depth, so that the minimum depth was whatever required clearance was also achieved, and junction was also satisfied that with the distance. So with 1.2 meter depth, overall construction or the overall depth was managed. But the side beams we are looking at, they were extended later because during the construction there was some difficulty. The original scheme was something different, and because of some constraint the scheme was changed, and then the depth of the beams were increased above the deck also. So this is something, I mean, semi-through kind of a bridge. The cables are placed on the side two beams. So there are two beams running along the bridge lines, 12.3 meter apart, and the carriageway is 11 meter in between accommodated. On both the bridges pylon, there is a footpath of 1.5 meter on outside of one beam. This is the photograph of the right photograph shows the first bridge was almost completed, and we can see there is an existing bridge where the spans were just very smaller. I mean 8 to 10 meter spans, and multiple spans were there. It was also extended multiple times. I mean, probably the railway yard was extended, then some spans were added, and the bridge was very old, so definitely it was required to be demolished, and the new bridge was required to be constructed. Vertical clearance also was increased as per the latest SOD, so the new bridge is higher than the older bridge. The span is, railway has asked to clear the railway boundary, so the span was chosen. The left bottom view shows both the bridge after completion. So we can imagine the difficulty in the construction, that how it was, because the situation was with the busy railway line at Nagpur, and train frequency is very high there. Also it is a Rajdhani route, so it cannot be closed, and the construction was very difficult. Now of course the construction cannot be done in a conventional way, that conventionally we erect the staging, we cast the deck and remove the staging after required strain. So that was not possible here. So the cantilever form traveller was designed. I mean, that is usual for bridge designers, that such cantilever form travellers are used. So the right side shows the general arrangement of that is a red is given as a bottom beam which supports the required shuttering for the bridge deck construction. The grey area of deck is already constructed. On taking support from that already constructed bridge, the bottom beam is placed. Then there is a top gantry, which in turn help in moving the that undercarriage further after construction of next bridge. So left shows the cross section. Below the cross section of the deck, there is a gantry which supports the cross beams, and on the cross beam all the shuttering has been placed. Then the deck concreting can be done. So originally it was conceived that only A and B will be supported. Now for design point of view, we can understand if only A and B were supported, then the reaction at A would be very high, and for that reason the beam was not capable. Then we were requiring to strengthen it much more. Then the decision was taken that we will support at C location, and that will be a temporary cable at C location. So that became a complicated from operation point of view, but we could manage with whatever constrained depth of girder and with whatever sizing were originally envisaged. So the overall construction was done without any support from below, except near the pylon. The first deck of say 14 meter on either side was constructed with usual conventional staging, and then this gantry was mounted on top of it to construct the deck further. So the further construction was segment by segment. Each segment was about 6.3 meter length, and then the permanent cable was stretched. So the deck becomes self-supported, not fully cantilever, and the load moves further for the taking further concrete. Now in this method, I mean any bridge, by any way we construct, we have to always keep our goal that whatever clearance is required, we have to satisfy. Whatever geometry of the bridge required or desired as per the vertical curve or whatever form, that has to be achieved at the end of its construction. So the first diagram shows the deflection diagram, which is a deflection due to dead load, whatever permanent loads are there. Now I have to construct a bridge with the reverse of that diagram. Then only the final geometry will come to the original one, which is desired one. So that is called a camber diagram. Now camber, in case of a conventional staging, it is easier. I mean, we can do the one stage, whatever the camber diagram is there, we can erect the shuttering in the form of camber, and then we can lay the concrete, and after removal of staging, it will come to the whatever shape is there. But in segmental construction, that is slightly a tricky one. Now in segmental construction, this is going on accumulating. I mean, the deflections goes on accumulating. Suppose there is a, I have shown the, for schematic, the 3 segment elaboration. S1, S2, S3, these are the 3 segments. Now S1 is erected, then it will deflect because of its self-weight. After erecting S2, S2 will also deflect, then it will deflect the S1 also. So forth and so on. So the reverse of the whatever deflections is there, that is accumulated curve, we can reverse as a camber curve. But here the concrete strength of S1 will be different when S3 is cast. When S2 is cast, it is different. So that we have to account it, and that is slightly tricky one. Nowadays the softwares are available where we can model such non-linearity. The overall behavior is non-linear. To capture this, the camber diagram, we have to model very precisely the concrete strain curve very precisely and the activity, because generally we plan something and at site it goes something else. So that we have to accommodate in the design. So factors affect the overall construction are the concrete strain at various times. I mean, not only the generally we designate any concrete strength at the 20th day, but here it is equally important to consider the concrete strength at different age, because the age of each segment is different at given point of time. Then second factor which affects the overall camber or the deflections is ambient temperature. If we have pure cantilever and if we measure the its survey in the morning, the levels will be different. If we measure it at the afternoon, it will be different. Similarly, the pylons are very tall. It has the effect of sun path, because these pylons were facing exactly east-west. So in the morning the pylon was deflecting on one side, on the evening the pylon was deflecting on the other side. So that also has effect. Then the assessment of construction load, that is very much affecting the design. So whatever weight of gantry initially calculated and whatever actually has built, there was a quite difference, and then we reiterated all the calculations once again, and we found that we are close by. So with that assessment of actual dead load and the construction equipments that contractor has planned, that has to be considered in such a calculation of camber diagram. Then of course whatever stages of construction that were planned, that has to be correctly modeled in the analysis itself, so that all the activities are captured very correctly. Like generally there are activities, they will erect for staging, they will put the concrete, then it will reach some strain, then the staging will be removed, then the deck erection gantry will be installed, then it will be moved further, then it will be temporary stress or whatever. All these activities are minutely noted down. Its timeline has to be fixed, because the age of concrete has also that effect. So I have to, that stages of constructions are also important, and those were correctly taken care. Nowadays the CEB FIB model is popular one to assess, analyze the concrete strength at different time. So CEB FIB model 90 was used. In that model, the concrete strength at any time can be considered with the expression mentioned here. Also, it calculates the effect of creep and shrinkage. I mean, the concrete deflates because of the sustained load, that is called creep. Also, it exhibits shrinkage. So, shrinkage in the initial period is high, and capturing that in assessment of deflection is very much important, and that is available in any modern software, and such modeling was done. Modeling was done initially with finite element method and shell element, but it was taking too long time to analyze, and then we shifted to some grillage model, and we found that the results were close by with whatever we model, and then we continued with the grillage model, which was faster to take trials, because anything which we do, it is not at one go. I mean, we plan something and at site it happens something else. So we have to reiterate the whole process and do the corrections for the next cycle. Then this grillage model was more effective, and so the grillage has been considered. Now the deck and tower monitoring is very much important during the construction. So initially we plan something, and as per that planning we give the designer from designer perspective, we give some output that with the assumption of loads and whatever the concrete data is there, we generally give the deflections of beam at various locations at various activities. Similarly, deflections or the values for the pylon deflections are also given. Then those are monitored at site, and then the correlation between the analysis and actual at site is done. So it is a bidirectional process. That designer gives some output, then it is cross verified at site. If there is a difference, then we have to cross verify whether the assumptions are going wrong, or any correction is required in the analysis, or any factors which are not really captured. So we have to see. In the initial period, we were not considering the temperature, and that has a great impact. So that was the, I mean, we can say that, I can say that was a takeaway in this analysis overall model. Rather, there were certain more also, like this whatever time cycle we were considering and whatever time cycle actually was happening, that was also different. So then we corrected everything, and we came to certain close by result after say third or fourth segment, and then we find that it was okay till the end of construction. So first 3-4 segment construction was slightly difficult. Now coming to the second bridge, that is ROB at Bardhaman. It is in West Bengal. That is also the similar situation like Nagpur. It has also, I mean, very busy yard and busy station. Bardhaman is a famous station in, I think it is in Delhi-Kolkata line of railway. There the total length of bridge was 188 meter. In Nagpur it was 200, it is 188 meter. But here the unbalancing was more. I mean, the pylon location was chosen outside the railway boundary. So it was further, I mean, from execution point of view, that was a very out decision, that the construction of pylon away from the railway line is always desirable, and that was done. So the span on main railway yard or railway station side was 124 meter, and back side it was just 64 meter only. It was a 4-lane ROB, so there is 2 carriageways of 7.5, then there were footpath as a mandatory requirement. So the general alignment drawing looks like this. The backside span is very short, almost half the length of main span, and the tower height is here also almost 51 meter tower was there. As we see, the front span is bigger, back span is shorter. We have to balance the weight at pylon, otherwise there will be a continuous unbalanced movement. So the section of front span was steel girder, I mean lighter steel girders, lighter steel hollow girders with minimum thickness of deck slab. Whereas on the back side, we have to generate the dead load. So the solid RCC beams were there, and the deck slab was also made thicker to balance the overall weight. The back side and the pylon was made integral. So pylon below the deck and the back span is integral and in concrete. So this much area is integral. Above this pylon is in steel. Steel segments were done. So by the time foundation and this backspan was done, all the girders as well as pylon fabrication was ready. And so erection of this pylon as well as erection of the front span was much faster as compared to our earlier case of Nagpur, which was totally in concrete. Now the construction sequence typically was planned like between the backspan was constructed first, the two piers and the backspan integral was constructed. Then the three steel pylons were erected using gantries, using crane, tower crane. Then the erection of first panel is done with again with the cranes, and those were fixed. After that, the steel members of each member, each segment were erected using the specially designed deck erection crane. I will show in next slide. So the material for the next segments was fed from the back side. There was nothing disturbance for the railway. That railway is below, and all the materials for the construction of deck on railway was fed from the back side. There is a crane standing on the first front panel, which supports these whatever feed segments are there. It holds the segment till it is connected to the already constructed deck. Then the permanent cables are stressed. Then here the deck slab was constructed with precast panels. So precast panels were placed, and then the remaining portion, small portion of in situ concreting was done. So construction wise this was much faster and much precise as compared to the earlier case. So the same sequence was followed till the end of construction. This is the earlier side was showing the second panel erection. Now this is the erection of last panel, 10th panel. The crane is moving for taking the erection of second panel, 10th panel, that is the last panel. The back staging was kept as it is till the end of construction, because it was required from the design point of view, because all cables were erected on the back side also stage by stage. Otherwise there was a huge bending moment on the pylon, unbalanced bending moment on the pylon. This is the photograph of deck erection crane which was designed and used in this project. The total weight was around 80-85 ton, and there was a balancing weight on the back side that was around 100 ton. So the total weight of this erection gantry was just 180 ton. Whereas in Nagpur it was almost 220 ton for the erection of 6 meter segment, whereas here the segment length was also longer, that 12 meter, because generally the steel plates are available in the length of 12 meter. So each segment on Bardhaman was 12 meter length on front side. Again the geometry control methodology was similar to whatever we did in Nagpur, but here difference is that the panels were prefabricated. Those were the steel prefabrication. The holding, whatever the bolt positions were already done in the already constructed deck. So there was hardly any chance to adjust the deck during the construction. So deck cannot be, in Nagpur we used to adjust the deck by adjusting the shutter levels, whereas this adjustment was not possible here. So the only adjustment was possible is through the pre-camber in the steel girder. So that was exercised. And whatever, if there is a difference after erection, then that was adjusted with the adjustment of cable forces only. So these were the two adjustments possible. The geometry control methodology is similar. After each activity, the survey readings were monitored, and those were compared with the theoretical expected in the design. In case of steel girders, the precision in erection as well as in the E value as well as the deflections expected were more precise as compared to the concrete one. So the geometry control in case of the Bardhaman was also much easier. After completion of bridge, the total bridge, we could, there were three girders. The uniqueness of this is there were three pylons and three longitudinal girders because of the depth restriction. We could achieve the geometry with plus minus 60 mm, and after wearing coat, that also was covered. And this accuracy was achieved with the panel length of 12 meter also. Had it been a smaller panel length, probably we could have achieved more precisely. Now this, after looking at the construction of both the bridges, I think the Bardhaman was planned after the Nagpur pylon was constructed. Then they took decision of shifting the pylon outside the railway boundary for safety reason and changing the deck from concrete to structural steel. So that was the decision from authority itself, and the construction was so faster that this, before completion of the second bridge in Nagpur, the Bardhaman was completed. Though they were started much later, it was completed very faster, and that's the reason now it is popular in railway. Now in Mumbai suburbs, some more bridges are planned like that to bridge the between east and west side of railway line. So such some more bridges will come in Mumbai now. So that is the popular solution in now railway for crossing the railway line. Now coming to the third bridge which I am going to talk. This is at Hyderabad. It is again a 234 meter central span, and there are side spans. The side spans are smaller. I mean, ideally for 234 meter span, we would have gone for at least 120, 125 meter side span. But because of the geometric constraint and the land problem, the spans were restricted to 90 meter, 96 meter. And the overall design of this bridge is basically, I'll show the next photograph so that it will be easy to appreciate. The overall design of the bridge is mainly aesthetic driven project. It was, initially the only 234 meter span was fixed, so we proposed some conventional option of cable stayed bridge with say rectangular sections of steel, which was easy to, after Bardhaman it was, so similar solution was proposed with 234 meter span also. It was cable stayed bridge, but then the authority says they were going to develop the lake for public place, and from that perspective they demanded that it should be aesthetically pleasing structure. So the architect came in. That was our first experience in infrastructure project at architectural century, which was very difficult in the initial time, but later on we collaborated together and came up with a good solution. So the dimensioning or the basic shapes were given by architects. Then all the detailings was done by architect. The right side shows the 3D animated view, which was imagined by architects initially, and the left is almost completed bridge, which are very much close by, and it is, nowadays it is popular in Hyderabad to visit this place, and it has become a popular place. Again, here the construction is of course segmental. The backspans were constructed using conventional staging. All the girders, all the segments are precast segment. On the back side, they were erected on the conventional staging, whereas on the front, inside the lake, it is not allowed to erect any. That was not even possible for erecting that much long staging. So it is done with stage by stage construction. The bottom view shows the closer picture of segment erection in place. Again, the analysis is the similar way, stage by stage analysis was done. Then the same was given on the drawing, and the expected levels were given, and then it was cross verified at each stage. Here the advantage was the deck is very steep. This is called extra dose bridge, which has got very deep beam and steep deck. It is not much sensitive for the deflection. So the geometry control itself was not much issue, but it has a disadvantage also. Once the deck is steep, the adjustment, if anything goes wrong, then the adjustment is also a difficult one. So whatever the deflection curve was required, that was required to be built in the segment construction itself, and that geometry precision was done in the casting yard itself. The segments were cast to the required shape, and then it was erected. Then some minor adjustments were done at site using shim plates or some kind of thing. So this was the backside fan, which was erected first on staging. Now it is ready for taking the next segment. Now the segment by segment are erected. So in between the stage is like that. The segment by segments were erected, and cables were stressed. Then the erection gantries are moved forward, and the next segment is held, and then the pre-stress. There were internal pre-stress as well as external pre-stress. So looking at all these three bridges, I mean the first bridge, I was it was very early of days of my career. Just I had experience of 4.5 years. Then I entered into that. Of course, I mean there were experts who were guiding me all the way. So that the first Santra Market Bridge turned my vision from earlier it was just putting some numbers and getting results and putting in the drawing or something was that. It changed my vision from actual numbers to the physical meaning of those numbers and adjustment, because the deflection at site and at correlation taught me a very, I mean, structure behavior I can judge from that. So that was the advantage. From the three projects, I could summarize that the important conclusion that the construction, in whatever the way a bridge has been conceived, that this will be constructed, because that the last stage of construction will be the first stage of service. So the service design has to be considered with the construction stage stresses. The behavior of structure during the erection and during the service are different. So analysis need to be done considering the detailed construction activities and then the whatever service loads are there. The concrete property changes as per their life, I mean the age of concrete. So in the initial days, the concrete is very sensitive. I mean the gain of concrete strength is much faster in the initial days and then it stabilizes. Also the creep shrinkage effects are very much high on the initial stage and it stabilizes on the 28 days or after that. Then the continuous monitoring, that cross verification with respect to the analysis and actual at site has to be done continuously and very meticulously. Then the deformation of temperature, as I said, some decks are sensitive to deformation, some decks are not sensitive. So, but anyway, that study has to be done in the initial stage itself, and the deformation due to temperature effect is required to be considered. Then after continuous monitoring, the required correction has to be done at each stage itself. I mean, we cannot just let it go on accumulating. It is very difficult to accumulated deflected shape to correct at the latter stage. So at every stage we have to cross verify and give the solution, feasible solution to correct the deck geometry. Then the most important point is assessment of construction load, because whatever we assess and whatever is at site, they are practically, I mean, maybe far away from each other. So the designer has to visit the site frequently and understand what the activities are going on and what type of material and what type of equipments they are really using, and that construction load precision has to be done. So that was my takeaway from all the three projects. After successful completion of Hyderabad Bridge, we and architect, I mean the structural team and architectural team further collaborated for this nice bridge. The left shows the animated view, and the right bottom and the right bottom view and the right side view. This is the Sabarmati foot-over bridge at Ahmedabad, which is almost completed, which will be inaugurated very soon. So again, that is a collaboration of structural people and architectural people in the infrastructure, which is very rare. So this is again aesthetic driven, but yes, structurally also we optimize it, and the nice bridge is now ready to for public, which will come very soon. There are two further bridges which are very located in Pune. We are working on it. This is Deccan Bridge for Pune Metro. Sarla Madam is present. We are working for Pune Metro, and this is driven from Mawla's Pagdi. I mean, the cross-section view looks like Mawla's Pagdi. So that was the architectural theme, and I mean the structure. This is going. I mean, talking on the structure itself is another lecture which will take more than an hour's time, because the erection of these arches and the behavior of these arches, then the tensile elements, whatever has been used, and then the optimization. So all these activities are done with, I mean, very with great efforts. I hope this will come in realizations soon. Let's see, because this bridge has not been started. And the third bridge, which is again architecture driven project, Again, it is in the Pune city itself, that is near Sambhaji Garden for Pune Metro, that is connecting to station. This is also FOP. This is architectural theme is driven from the shape of Tanpura. It is coming near uh, auditorium, Bal Gandharva, sorry, Bal Gandharva. So that is coming near Bal Gandharva. So his Tanpura is theme for this, and that is under construction. The pylon is started for the construction, foundation is complete, and pylon is almost completed up to deck level. So this bridge will also come. So that's all from my side. And thank you once again.
Any questions from the audience are welcome.
Spring elements which were shown in the third bridge.
This?
Yeah.
The staging is resting on not exactly on hard strata. It is resting on I'll not say loose strata, but not exactly on the rock. So the deformation of staging has to be considered. Otherwise, that pre-camber could not be done properly. So that spring values were the it was taken from plate load test. Some plate load tests were done in the randomly, and then those springs were decided.
And during construction, whatever the previously defined camber values, how much accuracy you could achieve?
At the, I mean, that is a total span is 234 meter span. So roughly 120 meter from either side is a cantilever. The final three segments were required to do, just the final three segments only were required to do the shimming. There was a difference of about 55 to 60 mm between the two cantilevers. The two cantilevers, because they were originally planned to be constructed symmetrically. In actual reality, it doesn't happen because the right side pylon was not accessible initially. Then some land issue was there. To solve that, it was withheld. So the right side pylon was constructed later, so obviously that deck was erected late. Then we decided to stop the construction of left side, but again that was a pressure because some progress has to be seen at site. So I mean left deck was constructed. But after all, also there was a 60 mm difference between the two side of cantilever in 120 meter span. But they were adjusted in three segments on either side. So total 6 segments were done with some correction at site with shimming plate and epoxy grouting, etc. And that was achieved.
Thank you.
Good evening, sir. The first Nagpur bridge that you were talking about.
Yeah.
In other bridges,
You have used the precast members, but in that bridge it was cast in situ.
That was the first experience. After learning in that pro, we changed from cast in situ to steel. And this is third one is of course, I mean that is architectural driven. So steel was preferable from a designer's point of view, but not from architectural point of view. So the third one was precast is always a faster construction. I mean the construction pace is faster.
that was the thing that I was worrying.
Why so much of hassle?
Taking the concrete strength
Yes,
and
I
everything.
mean the original tender was bid on that basis. So certainly we cannot change from concrete to steel. It is a costlier material. But at the end we found that had it been converted to steel, the life of everybody would be easier. I mean, but I mean some things are not in control of designer only. That has cost implication also.
I would like to know more about the CEB FIP model 1990. Does it only measure the compressive strength part, or
No, it gives the overall behavior of concrete. I mean creep, shrinkage as well as strength, and strength is directly affecting the E value, elasticity. So all the three parameters, those are considered in that.
is it freely available, or?
Yeah, in software now, if Midas, Lusas, like those software are inbuilt, that is available.
Okay, sir. Thank you.
Thank you.
Thank you, sir, for sharing us with the knowledge regarding design and analysis of cable stayed bridges with 3 live examples and the other upcoming projects. The construction methodology with pictures has truly expanded our horizon of understanding the cable stayed bridges. As a structural engineer, your lecture was so concise with explanation, design, criteria, factors affecting deflection, the CEB FIB model, the analysis, the need of grillage models, and other 3 bridges with how you moved from in situ to steel to precast. Sir, the lecture was phenomenal, sir. Thank you, sir. Thank you, sir, for such a beautiful lecture. I would like to invite our SB Joshi awardee, Mr. PG Venkatram, Chief Technology Officer at L&T Infrastructure, to present his lecture on Journey of an Engineer.
Good evening, everybody. Good evening, everybody. Can you hear me now? Sorry, thank you. At the outset, I would like to thank the College of Engineering, Pune, to actually have something that recognizes bridge engineers who contribute so vitally to the connection between peoples. In the olden days, one had to cross the physical obstructions with great difficulty, a river by a boat or other natural means, and subsequently we learned the art of bridging. And then the bridge became, sometimes some of our creations themselves became barriers. So like our roads, for example, they divide the city they divide our cities into parcels of land. After some time, these roads become barrier. So we become creative, and we create great separators to cross over one barrier created by ourselves. So it's nice to see that people like us who do our best to make life easy for others to recognize. To that extent, I definitely am grateful to College of Engineering, Pune's Alumni Association for recognizing these efforts in general. The only thing I feel very diffident about is looking at it as an achievement, because I still look at myself as somebody who knows so little about the whole aspect of bridge engineering. I still consider myself a student, in the sense great people have gone ahead before me who have created wonders, and in my early days I used to wonder myself, when will I ever get a chance to do such things. And when I take you through the various projects that I've worked with, each one of them have contributed a little bit of learning. And when it comes to the concept of learning, since I see a vast majority of the students here, and I am now a part-time faculty in IIT Madras, I would like to emphasize one thing to all students. We study engineering in a college like this. We take maybe on an average an Indian engineering institute that has about 7 or 8 subjects a semester, and we cover 8 semesters to get a degree. So 8 with 64 courses. But if you look at the structure of each course, a course is typically a 3-credit unit. So nowadays, everybody understands credits because the system of evaluation has been standardized across all the colleges. A 3-credit effectively means a lecturer gets in contact with you for a class, a 1-hour class 3 times a week. So 3 hours per week, 14 weeks makes 1 semester, 42 hours of lecture. The lecture covers, let us say argumentatively, 1 textbook. A typical textbook would be about 600 pages. Do you really believe 40 hours is enough to teach 60 or 650 pages? So what exactly are we telling each other? We passed this course. We have been introduced to the course. We just shook hands. We just got to know each other. Now it's the rest of us. The rest of our life is left to make sure that the 650 pages which we missed in the classes, we cover it up in the remaining part of our life. If you don't do that, we will find our professional life very, very difficult. Very difficult for us. So, the one thing which I keep looking for when I go recruiting people is how much of your learning ability you have kept yourself, the spark alive in you. Colleges can put in the, I won't even say the best of the foundations, but the rudimentary foundations. You need to strengthen it throughout your career. Throughout your life, you need to strengthen it. And remember one thing, somebody has very wisely said, whose life is it anyway? College has spent its 4 years, prepared you for something, their role is over. The remaining 40 years is your own. What you do with it, it's in your control. So that's why I would strongly recommend each one of you who is just beginning the career or have going to begin your career to make sure you never get away from learning. The classic example of we all call ourselves having a professional degree. All engineering degrees are called professional. What's professional about it? I check with you, you take your end semester exam as a measure of your work. You pass it. After that, what do you do about that subject? Memory erase button, because we have a next exam to write. But a true professional is somebody like Sachin Tendulkar or a Roger Federer, who plays a match, he wins it, goes back home, maybe takes a rest for a little bit, and then takes his racket, goes to the practice courts and hones his skills. How many of us do that? For us, structural analysis course 1 is over, structural analysis 2 course will start next semester, steel design 1, steel design 2, special structures. We are endlessly going in that cycle. In that process, somewhere along the line, we are forgetting the fact that we are the masters of our profession and we need to make sure that we continuously educate ourselves. So when I see that and when I see this recognition, I feel that I'm not yet ready for it. I have a lot more to learn. I have a lot more to do before I really make what I call as a significant contribution. So in that spirit, I will take you through to few of the projects. Unfortunately, when I started the preparation, I had no idea what would be the time limit given to me. To that extent, I would request your organizer next time to tell the speakers in advance. I suspect I may overshoot the time. In that case, I will cut out some of the things. But I hope I get a chance to take you through all the projects that I would like to talk about, because each one of them has taught me something that is unique, which I have not forgotten, which carries on from one project to other, and that's what you will recognize in your life as your professional growth. So, the first project, I was all of 24 when I got to do this job. My first job after coming back from US, finishing off my masters, and the project was, and it is the only example of a segmental bridge in railway. Railways don't like segmental bridges. They like their monolithic structures. Metros also run rail, but when I mean railways, I mean Indian railways. They hate segmental bridges. This was the first and the only example of it. And the background behind why it became a reality also, you should know. You should blame it on the first recipient of this award. I don't know whether you remember the list. It was Mr. E. Sridharan. He happened to be the general manager in Southern Railway when this project was conceptualized. And he is not averse to doing interesting and new things. He has done many, many new things, introduced new things, new contractors, new construction techniques, and very boldly. So this was an example where he said, okay, let's try out the segmental bridge. But what was most shocking was Stoop consultant who decided to try me out designing the work. What did I know about Priestess Concrete? Nearly zero, other than passing the course. Okay, other than that. What did I know about segmental bridges? I hadn't seen one in my life. What did I know about priestessing? Nothing. Launching? Nothing. So it was a big learning exercise for me. But that's where the caliber of your organization, Yogesh will vouch for it. We've all gone through the same companies, two consultants. They had a great bunch of seniors. I had past recipients of this recognition, also my mentors, my guides, my bosses, Sri Joglekar, Mr. N. Raghavan. They were all my mentors in Stoop in those days. And I was a green 24-year-old engineer doing this design. They gave me one sample design. This is what it was conceptualized early. These are the changes. You follow the step. And the first learning step is always follow the footstep. You can break your own path after you know what the pitfalls are. But initially learn to walk on others' footsteps. Nothing wrong with that. That's how the Japanese learned the concept of good product engineering. Initially they copied. The early Japanese products were very third class, you can say. I'm not saying it's a great bridge. For me, it's a lifetime of memory. A lifetime of memory in which I got to work on this segmental bridge, and I didn't know what segmental bridge was. The only thing I did was, at the end of the design, I said, I will not go support this project unless you allow me to go and visit the site and see it during construction. This I want to encourage each one of you when you take up your profession. The moment you finish it, if you become a designer, that is, you will be office bound. And I find most people like office bound jobs. They don't like the site works. It's a rough, difficult place. No malls, no theatres. It's a midst of nowhere, especially no infrastructure. That's why we are going there to build one. So that I insisted, because I find that every visit to the site is a great learning experience. And now onwards, I would encourage all of you who go to these construction sites or whatever construction activities going around you to look at it from an engineer's perspective rather than a layman or a tourist perspective. It may be beautiful structure, but there are a lot more heartaches in realization of that. So, as I said, this was a modest span, what we call as 100 feet in the railway parlance, and it was built across the backwaters of Kerala. And what you can see is actually the launching girder of that day. Please remember that this is a launching girder of the 80s, very poorly mechanized or virtually no mechanization. It is rolling on the back on the erected span, and the front is moved, as you can see, by a barge. The barge supports the front end, and the barge is guided on forward. It runs, and then you see a lot of these cross trusses. Nowadays you will find a more sophisticated arrangement, as you have seen in Durgam Cheru, where they showed wire, suspenders, mechanical lifting. These are all chain pulley blocks. You had no great mechanism. So you can understand that the construction engineering, construction activity, design is continuously changing. When we did this design, we did not have a computer. There was no personal computer. In 1986, Stoop bought the first personal computer, spending 1 lakh rupees on that, and they had a 6 months management note to say the cost-benefit analysis. You won't believe it, it had a total memory of 186 kilobytes. It ran a program, but you won't believe it, I have designed complex bridges on it. I have designed, subsequent to this, I have designed chimneys, I have designed cooling towers on it. It's possible. But today in my office, an engineer comes, sir, I click this button, I need to change this laptop, it's not fast enough for me. I don't know at that time whether to laugh or cry. You're not helpless. It's just a viewpoint of view. That's not to say that from those days you didn't have the tools to do multiple iterations. So you had to understand the basic principles far better today. Today, unfortunately, with the availability of complex analysis tools, which he said, with which very, very complex deflection calculations, camber corrections are all made easy. In those days, I can tell you, when I did Thane Creek Bridge, I'll come to that, my life was far more miserable than his. So, when you do this, you have to know your first principles right. Then you reduce the number of iterations. Then there is a difference of approach between the designers. So at 24 years of age, I joined this company. 25 May, I remember very clearly, this design was handed over to me in September 84, and the design was finished. It took me 5 months to finish the design because I had only calculator. The design notes, there was no Word, there was no Excel. You had to write handwritten notes. Multiple copies were made by writing them on tracing sheet and taking ammonia prints. There was no Xerox machines. That's an atmosphere under which these bridges, that's why I say you must recognize people like Joshi sir and all that, who did this kind of work when things were much worse. I mean, okay, I can still say I had calculator. They had flight rules. Some of them had log tables. Today if I ask you log tables, so what's that? Precise calculations were done on that. So I'm just telling, these are, I just want you to recognize all these, software, computer, hardware, all of them are tools. The operator is you. If you are not knowledgeable and skillful, they are useless. They are like giving nuclear weapons in the hand of a child. You will blow yourself out. That's also possible with them. So it's not, please don't get enamored by what Midas can do, what Sophistic can do. You should ask what I can do with that. That's more important. The rest is all, anybody can be trained to use a software. So please don't get enamored by that. I can tell you I'm the worst user of software. But in my office I can actually tell most of my people what this software is capable of. By working with them, you give me a problem to model, I will take ages, my junior colleagues all, they will finish it very fast. That is the skill in using a tool. But that doesn't tell you why you should use that tool and how you should use that tool. And that's where we as engineers come into the picture. So please, somewhere along the line, take away your enchantment for knowing newer and newer software. Please remember, you have a problem which I cannot solve by hand calculation, take too long. So think of them as assistants, not you. They cannot replace you. Don't take it to that stage where you start thinking that I buy a software, I can do it with 4 engineers less. Impossible. That's a wrong view. So this is an example of the same thing in the construction side. We had less mechanization, but the concept of mechanism, movement, launching, all that was understood. Now, what you have to appreciate is when these segments are resting on these transverse stresses, they are like slices of bread. To understand segmental construction easily, you think about it as a